Hello everyone, Ms. Meek here, and today we are going to talk about the shapes of distribution. So there's two things that the shape of distribution talks about and explores. So the shape of distribution talks about one, symmetry. So determining if your graph is symmetrical. So symmetrical or what we call asymmetrical. So if you remember back when you learned about symmetry, what that means is that if I have something like a heart and I divide it in half, my two heart halves, this side and this side, are about the same side. They have symmetry. So if I cut it in half, one side looks like the other. If I have a shape that doesn't work for, so maybe something like this, when I cut it in half, this side does not match this side. This does not have symmetry. No symmetry. But my heart does. So we have to be able to look at a graph and determine, is it symmetrical or is it not? If I split it in half, will each side be the same? If the graph has symmetry, that means that the mean is going to be right in the middle of our data, and it's going to be very reliable for us to use. If it does not have symmetry, then that means that our data is going to be what's called skewed. And when our data is skewed, that means that the mean is not going to be the center of our data, and it's not going to be as reliable as we would hope. And so instead of using the mean as our reliable piece of information, we would probably use the median or something like that because it takes into account for skewed data. So let's go ahead and talk about, well, what is skewed data and what does all that have to do with anything? First of all, here are three different types of graphs. And again, talking about that symmetry, if I was to divide this graph straight in half, there is definitely a line of symmetry because both sides look the same. Okay, if both sides look the same, then that means that we have symmetry here. So this is going to be called symmetrical. Now, another thing that we call symmetrical, or another word for symmetrical, is we'll say that the data is normal, which means that it is not skewed, that each side of the graph looks the same. And when each side of the graph looks the same, when we have that symmetry, what's really awesome about that is that our mean is going to be, again, straight up here in the middle. It's not going to be leaning one way or the other, and so the mean is going to be the reliable thing to use in a symmetrical piece of data. Now, what happens when we don't have that symmetry? So, for example, if I were to divide this graph in half, each side does not look the same, okay? It does not look the same at all. I think we can agree on that. So this would be an example of something that does not have symmetry, and so we would say that this is asymmetrical. Asymmetrical means not symmetrical or no symmetry. And when we don't have symmetry, that means that our graph is skewed. So let's talk about what skewed graphs means. When I have a skewed graph, that means that my peak is not in the middle. Over here, our peak was in the middle on that first graph. Here, our peak is over here to the left. When our peak is to the left, what that means is that I have my data is going to be skewed, and it's going to be skewed, what's called skewed right. So this data is actually called skewed right because the peak is over here to the left, and then our data starts to wind down to the right. Now that data winding down to the right is actually called the tail of the data. So when your tail goes to the right, you are skewed to the right. And what happens because of all of that is your mean gets shifted over. Your mean is no longer in the middle of your data above the peak like it is in symmetrical data. Your mean gets shifted over and your mean gets shifted to the right. And so again, the reason why this is called skewed right is because your mean is being pulled to the right, the tail of your data is going to the right, and your peak is on the left. And so everything gets shifted over because of that. Now, what this means is that you have also another word for skewed right is called a positive skew. Again, a positive skew just means that everything is being shifted to an increase. So everything is being shifted up the graph up the number line there to bigger numbers than it should be, because again, this data is all going to be skewed that way. Now, when the peak is over here to the right and your tail of your data is going to the left, that means that your mean is going to be pulled to the left as well. That is called skewed left. So again, down here, this third graph here is asymmetrical. It does not have that line of symmetry. And the peak is to the right, and that means that the tail end of your graph is going to the left. It also means that your mean is going to be shoved or pushed or pulled towards the left as well. And so we would say that this is skewed left. Not skewed leaf. Sorry about that. Let me fix that. My mind must be still on leaf plots. We would also call this a negative skew because your mean is being pulled down. So your mean is being pulled down to the lower end of your graph or the lower end of your number line. And so that means it's getting smaller. Whether it should be or not, your mean is no longer reliable because this is not symmetrical data. So speaking of all of that, let's talk about how I can use this. Now, the examples I gave you were histograms. This also, you can look at data for dot plots as well. It's a little bit harder to see with box plots and with stem and leaf plots, but you can actually look at them and kind of determine the skew. I will tell you the easiest graphs to find skew on are histograms and dot plots because it gives you that really good visual. So we're going to make a dot plot here real quick. My first dot is a 5. My next dot is a 20. I have a 10. I have another 20. Another 20. 15. 10. 15 again. 15 and 20. There we go. So I've made my dot plot, and it says to describe the distribution. So first of all, if I were to divide this dot plot straight up in half, does each side look the same? No, it does not. So this does not have any symmetry. So this is going to be asymmetrical. So the first thing I can write about this graph is that it is asymmetrical, which means that it does not have symmetry. That means that my graph is going to be skewed. The peak is over here. And when the peak is to the right and the tail is going to the left, that means that my mean is also being pulled down to the left. And so this is going to be skewed left. Again, that's also a negative skew because your mean is being pulled down towards the negatives. Okay, it's getting smaller. And so again, this is going to be considered a negative skew as well. So these are all ways that I can describe the distribution. Now again, we've mentioned this before, that when you have skewed data, it affects what is the best way to measure the center of the data. Most people think the mean is always the best way because it tells you straight up the average of all of these numbers, but that isn't always the case, because if you have an outlier or if you have skewed data, as we have determined, that mean can get pulled to be lower than it should be, or it can be pulled to be higher than it should be. And so when you're trying to figure out what is the best measure of center, that's what that's called, the measure of center and the measure of spread. So the measure of center is your mean, median, your mode, all of that is, I can't spell today, guys, I'm so sorry, center, there we go. The measure of center is where is the middle of your data? Where is all of your data hanging out? Okay, and then the other measure that's important to us is the measure of spread. How spread out is your data? And symmetry affects that. So what you have to do is, if you want to know what is the best one to measure or to use for a group of data, you have to ask yourself one super important question. And that question is the data symmetrical? If the data is symmetrical, if the answer to that question is yes, yes it is, then you are going to use the mean for the center, and you are going to use the IQR for the spread, because those are going to be the best measurements for that. The reason why is because if everything is nice and pretty and symmetrical and each side of the data looks the same, the mean is going to be with the peak, and the peak is going to be right in the middle, and everything is going to be beautiful, and your mean will be a very accurate representation of where all of your numbers are hanging out. However, if the answer to is the data symmetrical is no, it is asymmetrical, you can't use the mean for the center. You're going to have to use the median. The median does not care about outliers. It does not care about how the data is shifted. It puts all of the numbers in order, least to greatest, and it whittles it down, starting from the outside, going in, and finds that middle number where all the data is hanging around. So it does not care about big numbers or little numbers. It's going to whittle all of that down to one number in the middle. And so that's really great for when you have data that's not even or evenly distributed or it's asymmetrical. It will give you a really good idea of that middle number, and it won't be affected like the mean would. And then the spread, you're still going to use the IQR. The IQR really is just overall the best measure of spread. It tells you how spread out everything is. It tells you how spread out the middle of your data is, and it's great. Again, just as a reminder, outliers are not the mean's friends. Outlier will cause your data to be asymmetrical. And so again, if you have really obvious outliers are numbers that are way bigger or way smaller than the rest of the data. It's going to affect your average. It's going to affect your mean. And so you would need to use the median instead if you have outliers. All right, guys, that was a lot of information. I hope this cleared up any confusion you had about the measure of the center, the measure of spread, about the symmetry of graphs or the asymmetricalness of graphs, and how that all comes into play when you take a histogram or a dot plot or whatever you're looking at and try to describe it. All right, I will talk to you later. Bye.